Is to list the numbers in order from least to greatest. So that means from smallest to biggest. So what we need to do is we need to turn all of these into decimals. So we first have 6.25, which is going to just stay 6.25. You can add an extra 0 onto the end of it if you want, which make that 6.250 like that. Then for 43 over 7, we would do 43 divided by 7, which gives us 6.4142. And then for the square root of 39.5, that's not what I want to do. Okay. It gives us 6.284. So we're going from smallest to greatest. So the first thing I look at is I look at my ones place. Well, in my ones place, these are all sixes. So now I'm going to look at my tens place. In my tens place, I have a 2, a 1, and a 2. So out of all of those, which one is the smallest? The one with the 1, which would be 43 over 7. Then I have, so I'm going to cross that off, and then we're going to look at the next smallest. Well, now we have a 2 in the 10th place and a 2 in the 10th place, so I have to look at the hundredths place. This one has a 5, and then this one has an 8, so which one is smaller? The one with the 5. So the next one would be 6.25. Which leaves us with the last one, which is 39.5. For the next question, it says, between which two whole numbers does the square root of 125 belong? So we have to look at our perfect square roots, and this perfect square root that comes before the square root of 125 is the square root of 121, which is 11. And then the square root that comes after 125 is 144, which gives us 12. The other way we could do this is we could just put the square root of 125 into our calculator, and we see that it gives us 11.1. Well, like on a number line, here's 11.1. The number that comes before 11.1 is 11, and the number that comes after 11.1 is 12. So it would come between 11 and 12. The next one says, the map shows the location of Dave's house and other locations that he frequents. The distance between some of these locations are listed in miles. What is the distances from longest to shortest? So we need to take these and compare them, and we're going to do that by turning them into decimals. So for 4 1/9, the first thing I'm going to do is I'm going to write down this 4 that is right here. And then I'm going to add the decimal for the 1/9. And so we do 1 divided by 9, which gives us 0.1 repeating, so we have 4.111. Then we have 2 square root of 5, so I'll do 2 in my calculator. I will do 2, and then second square root of 5, and that gives us 4.472. And then for the last one, we have 35 over 8, so we would do 35 divided by 8, and that gives us 4.375. And now we're going to put them in order from longest to shortest. That means from biggest to smallest. So out of those three numbers, which one is the biggest? That's going to be the 4.472 because of that 10th place. So that's going to be 2 square root of 5. And then the next one is going to be the 4.375, which would be 35 over 8, which leaves us with the last one, which is 4 1/9. Okay, this question right here says sets A and B are subsets of the real number system. A is rational numbers and B is irrational numbers. Which Venn diagram best represents the relationship between set A and set B? So basically what this one is asking us to do is realize that rational numbers and irrational numbers have absolutely nothing in common. And if they have absolutely nothing in common, that means they can't overlap whatsoever, which means that that is D. All right, this one says, is negative 9.6 an integer? Explain. So is that an integer? No. It has a decimal. Integers have no decimals or fractions. All right, this one says, what value of x makes this equation true? So we learned these in 7th grade. We haven't looked at them in 8th grade yet, but hopefully we kind of remember. If not, there's some steps over here off to the side. Step 1 says to circle the variable and the coefficient. So the variable and coefficient, this is the variable, and then the coefficient is the number that's attached onto it. So that's going to be 5x. So we did that step. Next step says to get rid of your constant. The constant is the number that's by itself but next to our variable. So that's going to be positive 12. So we do the inverse of positive 12 on both sides. What that means is the opposite of positive 12. So what is the opposite of positive 12? Negative 12. So these are going to cancel out, and that leaves me with 5x. Now in my calculator, I'm going to do negative 33 minus 12, which gives us negative 45. So that was step 2. And then for step 3, it says to get rid of the coefficient by doing the inverse of 5x on both sides. Well, we have to ask ourselves what operation is happening to 5 and x? That's multiplication. How do you get rid of multiplication? Division. So we divide both sides by 5. So in my calculator, I have negative 45 as an answer, so I'm just going to hit divided by 5, and that gives me that x equals negative 9. All right, so it wants us to start by putting 0.0000288 in scientific notation. So remember, when we do this, we have to first see if our number is a decimal or a whole number. So in this case, is it a decimal or a whole number? This is a decimal, so is your exponent going to be positive or negative? It's going to be negative because decimals have negative exponents. So here's a negative, and then it says I have to draw blank loops to get one digit in front of my decimal, so my exponent is blank. So let's see how many loops we have to draw. So we draw 1, 2, 3, 4. Now a lot of us are going to be tempted to stop here, but in front of our decimal right here would be a 0. We don't want a 0 in front of our decimal, so we have to go one more, which would be 5, to have 2.88. So that puts 2.88 right there. And then how many loops did we have? We had 1, 2, 3, 4, 5 loops. So the exponent is negative 5. Also, if you can't see the loop super clearly, what you can do is you can just put dashes underneath. So that's 1, 2, 3, 4, 5 dashes underneath it. All right, and then this one, it wants it to turn it into standard notation. So this one says the exponent is positive, so I will have a whole number or a decimal. That's going to be a whole number. Decimals are negative, whole numbers are positive. My exponent is 8, so I have to draw how many loops? 8 loops. So we're going to start with 6.03. Remember, we're making this into a whole number. If I were to move it this way, that would make it into more of a decimal. I want to move it the other way. So we're going to draw 8 loops. 1, 2, 3, 4, 5, 6, 7, 8. Into all of those blanks, we're going to put zeros. So we have 603, and then we have 1, 2, 3, 4, 5, 6 zeros. All right, this one wants to know the lap times from fastest to slowest, so we need to turn all of these into decimals. So we're going to start with this one. We keep the original 40, and then for our fraction, we just add a decimal and we divide 1 divided by 3 in our calculator, which gives us 0.33. And then we have 40 and 3/5, so I would say 40, add my decimal, and then I would do 3 divided by 5 in the calculator, and that gives me 0.6. So we're just comparing these, and it wants this from fastest to slowest. So which one of these has the fastest? Well, we're talking about lap time. So think of racing on a track. The person that has the shortest amount of time is the person that went the fastest. You would much rather have a person on your team that runs like a 5-minute mile than a person on your team that runs like a 12-minute mile. So the shorter the time, the faster it is. So in this case, the fastest person was Judy because she has the shortest amount of time. So we come over here and we see that these two do not start with Judy. Then we look at second place, and second place would be the second fastest time or the second shortest amount of time, which is Kelvin with 40.3. So it's not going to be this one, so that would leave us with D. All right, this one says fill in the blank with a greater than, less than, or equal to sign. So we have negative 12 and 3/7. So this is negative 12, and then we do 3 divided by 7, and that gives us 4, 2, 8. And then for negative the negative square root 138, we do negative, and then we type in 138, and that gives us negative 11.747. Now, would you rather have negative $12 or negative $11? You'd rather have negative $11, so that makes the negative 11 bigger than the negative 12. This one says, between which two whole numbers does the square root of 158 belong? So I'm just going to put that into my calculator, the square root of 158, and that gives me 12.5. So on a number line, I have 12.5. The whole number that comes before 12.5 is 12, and the number that comes after is 13. That would be 144 and 169. This one wants to know what what this number is written in scientific notation. So right now we have a decimal, so the exponent is going to be positive or negative. The exponent is going to be negative. And then we have to figure out how many loops we have to draw to have one number in front of the decimal. So we would draw 1, 2, and remember we can't stop here because right now that is a 0 number that's in front of the decimal. That would be written as 0.1, and we don't want that, so we have to go one more time. So that's 1, 2, 3 loops. So the exponent is 3. So I would have 1.332 times 10 to the negative 3. All right, this one says a grain of sand has a diameter of approximately 0.0000083 meters. How is this number written in scientific notation? So we have a decimal, so is our exponent going to be positive or negative? Negative. And then we need to figure out how many loops we have to draw. So we have to draw 1, 2, 3, 4, 5, and we can't stop here because that would put my decimal here. So we have to go one more place, 6, to make it into 8.3. We'll get back to the equations. So I draw a line through my equal sign, circle my variable and the coefficient, and then I have to do the opposite of positive 11, and the opposite of positive 11 is negative 11. Cross those off and drop down your negative 8x. Then we have negative 17 minus 11, so I'm going to put that into my calculator, and that gives us negative 28. And then at this point, I ask myself what operation is happening between negative 8 and x, which is multiplication. And how do we get rid of multiplication? Division. So we divide both sides by negative 8. So I just had negative 28 in my calculator, so all I have to do is press divide and then negative 8, and that gives us x equals positive 3.5 because a negative divided by a negative is a positive. Next one, we draw a line through our equal sign. We circle our variable and the coefficient, and then we do the opposite of positive 14. The opposite of positive 14 is negative 14. So in my calculator, I do 32 minus 14, and that gives me 18. Drop down my 2x. What operation is happening between 2 and x? Multiplication. How do we get rid of multiplication? Division, so we divide both sides by 2. 18 divided by 2 is just 9. This one says Julian and Jules need to each set up a lemonade stand to raise money for the local shelter. Jillian wants to sell lemonade for $1.50 per cup, and her mom gave her a $10 donation. Jules wants to sell lemonade for $2 per cup. Write an equation that represents C, the number of cups of lemonade that Jillian and Jules need to sell. So on this side, we're going to have Jillian, and on this side, we're going to have Jules. Now, for Jillian, remember, the number that is attached on to our variable is the one that happens multiple times. So which one happens multiple times? That would be the $1.50 because we see the word per. And then what happens once is the $10 because her mom donated that to her and she only donated it once. For joules, there's only one number and it says $2 per cup, so we know that the $2 happens over and over and over. The last question says, 2 8th grader students are running a bake sale. Alex is selling cookies for $1.50 each and has already earned $120. So we know that the $1.50 each means that happens multiple times. So it's going to be attached onto our X. And then has already earned $120 is a starting value, so it's by itself. And then it says Jordan is selling $2 each. So we see each, so we know that $2 is going to happen multiple times, which means it needs to be attached onto X and has already earned 80. So we start with that. So that means it only happens once. So we're looking for an equation where $1.50 is attached onto X or onto a letter and where 2 is attached onto X or a letter. So if I look at this one, I see 120 attached on, but 120 isn't supposed to be attached onto a letter. Then I see $1.50 for this one is attached on, and I see that 2 is attached on. And right here we said that $1.50 needed to be attached on and $2 needed to be attached onto our X. And then this one could also work. We just have to make sure that the $1.50 and our 80 are paired together. And in this case, they actually are. So let me see why this B is wrong. Oh, this one's wrong because the 2 is attached onto $1, is attached onto $120, and those aren't in the same sentence, so they don't go on the same side of the equation.